All right. Well, it's Friday night here in Maui, and I was just thinking back to when I was in college. Um, a buddy of mine, Brian Orinick, and I decided at some point that the Sunday night homework crush that every college student has wasn't really working for us, and so we made a pact that on Fridays after school got out, 2 or 3 o'clock, before anything started happening, which was usually around 8, that we would do work every Friday afternoon, and we set a timer, 2 hours, And at the time there were no cell phones, so we couldn't be bugged by computers and stuff like that. And we did this for our junior and senior years, and it worked wonders because everything was still fresh from the week. Whereas if you didn't do it, Sunday night would come and it would seem like the work you did the previous week was miles away, especially if you snowboarded or rock climbed all weekend, which is what we did. So here it is Friday, and I felt like doing some of these homework problems just to sort of give you a feel of what I'm expecting. So, all right. So this is from section 4.4. This is problem 18, and it gives you a function f of x equals minus x to the fourth plus 6x squared minus 4. And your end goal here is to graph this thing with maxes and mins and inflection points and intervals of concavity and zeros and all that stuff appearing. So to that end, let's just start taking derivatives here. So the first derivative is minus 4x cubed plus 12x. And since we're here, let's do the second derivative. That's minus 12x squared plus 12. All right, so let's find maxes and mins. So we take f prime of x, which is minus 4x cubed plus 12. We set that equal to 0, and that's equal to 0 if and only if I'm going to factor a minus 4x out, and I'm left with x squared minus 3, and that's equal to 0 if and only if x equals 0 or plus or minus root 3. So because of the sign chart I'm about to make, I'm going to break this into bite-sized pieces. All right, and here we go. Here's our critical points, our f prime critical points. Okay, so we make a sign chart. So this is a sign chart for f prime, and we have 0 in here, and we have minus the square root of 3, and we have plus the square root of 3. Okay, and then we have minus 4x, x minus root 3, x plus root 3, and then the end result is the product of all of those. So this guy is going to be positive on this side and negative over here. This is going to be positive over there and negative everywhere else. And this guy's going to be positive over here and negative everywhere. So we have plus, minus, plus, minus. So here's the shape of f. And so there is a local max at root 3, f of root 3, minus root 3, sorry. A local min at 0 comma f of 0, and then another local max at root 3 f of root 3. All right. Okay. Okay, so what was the second derivative here? The second derivative was minus 12x squared plus 12. And this equals 0 if and only if negative 12 times x squared minus 1 equals 0. And this is true if and only if and that's plus or minus 1. So plus or minus 1 are f double prime critical points. Okay. So let's be careful here. So I put in minus 1 and 1. This is the sign chart for f double prime. So I have x minus 1, which is positive here, negative here, and here. X plus 1, which is positive here and here, negative. And you got to deal with this negative 12, which is negative everywhere. So I have negative, positive, negative. So concave down, concave up, concave down, and we have inflection points at plus or minus 1, comma f of plus or minus 1. All right. Let's see here. Anything else we can get from this? So if you let u equal minus x squared, no, let's let u be equal, so this is minus u squared plus 6u minus 4. Does this thing factor? B squared. Oh, it's got square roots. That's gnarly. Okay, we'll figure it out. Do we have anything? Why are there square roots? The y-intercept's at minus 4. So there's that. We know... God, I don't want to do this, but I think I have to. Oh, okay. Here we go. So f of x is minus x to the 4th plus 6x squared minus 4. Okay, so f of both plus and minus root 3 are going to be minus, so root 3 squared to 9 plus 18 minus 4, which is 5. Right, so root 3 squared is 3, 3 squared is 9. Okay, root 3 squared is 3, so 16. So there we go. So, all right, so we have, so what do we have here? We have maxes at root 3 minus root 3, comma 5. So go 1, 2, 3, minus 1, 1, 2, 3, 4, 5. So square root of 3 is somewhere over here. And minus the square root of 3 is somewhere over here. So we have, all right, so this is fun. This is a puzzle, remember that. So root 3, 5 is a max, and minus root 3, 5 is another max. Okay. And I think we had a min somewhere. Where's the min? The min was at 0. And what's f of 0? Oh, it's minus 4, so that's there. Cool. So we know there's a max here, a min here, a max here, and because it's 4th degree, it goes down. I don't know where these zeros are, but they're somewhere in there. And that's that. So let's look at Desmos just for fun. I want to see where those zeros are. So minus x to the 4th plus 6x squared minus 4. So that looks good. And the zeros are what? Just past 2 and just before 1. So just past 2 and just before I put them right on. This one's just before 1, so that one's. So yeah, this is 5 out of 5. Killed it. All right. Next. This is 4.4 problem 40. And they give you this rational function. The first thing I did is I wrote it like this, because that's what we're used to seeing, right? And before we do anything, we know all this stuff about rational functions. I got a vertical asymptote where x equals 0. Since there's a vertical asymptote through the y-axis, there is no y-intercept. I have a 0 at minus 2 to the 1/3 comma 0. And I'm going to blow your mind here. All we ever did was as if this was 1 degree bigger than the bottom, right? It was like, but this is 2 degrees bigger. So instead of having a slant asymptote, we have a quadratic asymptote at y equals x squared. All right, so notice we haven't done any calculus yet. This is stuff that I taught you and you learned in Math 100. Okay, let's do some calc. Y prime is 2x minus 2 over x squared, which is this. And so y double prime is 2 plus 4x to the minus 3. Okay. So let's find max and mins. We have y prime equals 2x minus 2 over x squared. And we set this equal to 0, and that's true if and only if 2x cubed minus 2 over x squared equals 0. Finding a common denominator, right? Which is x squared, and I'll give us the x cubed on top. Okay, and this is true if and only if we have 2 times x cubed minus 1 over x squared, and this equals 0 when x equals 1, and it's undefined when x equals 0. So these are our, these are our f prime critical points. Now we already know that x equals 0 is a vertical asymptote. We still need to put it in our sign chart. So we have 0 and 1. I have 2 times x cubed minus, oh, the x squared fixes that. Alright, so nonetheless, we're going to be complete here. That's positive everywhere. X cubed minus 1 is positive to the right, negative elsewhere, so it's negative, negative, positive. So it's decreasing along here and increasing along here. So we have a local min at 1 comma f of 1. Okay. And what is that? That's 1 comma. What's f of 1? F of 1 is 3. That's nice. Alright, second derivative. What did we get? 2 minus 2 plus 4 over x cubed, which is 2x cubed plus 4 over x cubed. So this is equal to 0 if and only if x equals the cube root of minus 2. And it's undefined for x equals 0, because again, that's an asymptote. So we make a f double prime sign chart. We got 0, and we have this funky number here. So 2x cubed plus 4. And x cubed. So this guy's positive to the right, negative here. All right. And this thing is, what? It's positive here, negative here. So plus, minus, plus. So, okay. Concave up, concave down, concave up. Now remember, this is a vertical asymptote. So even though the concavity changes, because there's no point there, you can't have a point of inflection. And this is an inflection point. And I think that's, where did that number come from? Didn't we have it before? That's one of the zeros. Cool, so we've already got that number. So inflection point at minus 2 to the 1/3. All right, let's try and graph this thing. And I'll be honest, I'm going to do all the old stuff first. So there's a vertical asymptote at, it's too big. Oh, it's just the shade. Let's do this instead. So there's a vertical asymptote. I still want it to be darker. There's a vertical asymptote. Right pen. Took all the, there we go. Vertical asymptote there. All right, now for the new fun stuff. I have 1, 2, -1, -2. We have a quadratic asymptote. That looks like that. We have a 0 somewhere. Where the hell is it? -2 to the 1/3. I bet it's about right there. Oops. I bet it's about right there. And we know what? What else do we know? We know that it is concave up. Huh. Concave up from -infinity to 0. So I know it goes, oh. It goes like this. Because it's concave down from -2 to the 1/3 to 0, okay. And then it's concave up. Oh, there we go. Concave up along here because it's following this asymptote. And then from 0 to infinity, it's concave up. So it must go. Holy crap. Oh, don't we have a minimum somewhere? I forgot. There is a min at 1,3. Thank goodness. So it's 1,3. So yeah, so it does this. It comes down along here, and then it goes up like that. That's like the coolest problem I've done all day. I'm so glad I took this night to do this. X squared plus 2 over this. Let's check it out. I feel confident about this. X squared plus 2 over x. X squared plus 2 over x. Boom. Let's put in the asymptote here. Y equals x squared. Can you see that? The way the asymptote works? It's a quadratic asymptote. And killed it. Oh man, love that problem. All right, I got one more for you here, just to give you a flavor of each part of this homework set. These should be models for the sections within the section. So I assigned 4.4 59. Hold on. Right, I assigned 59, and since I didn't assign any other in the section, I'm going to do so this is what was assigned. and I'm going to do 60, which is just exactly like 59. So what you're given is you're given a derivative, and you're asked to produce a graph for f, okay? Now, not all these are going to be the same because we don't have any points on our function, but they are going to have the same shape and the same sort of place where the max and mins are. So check this out. So your book doesn't do this right either, so we're going to do it my way, okay? So first of all, we want to make a sign chart for y prime, and your book tells you to make a sign chart for y double prime, which we'll do, but I think that this chart is more important, okay? So this is a sign chart for double prime, okay, and so this thing factors, and you get critical points at -2 and 3, right? And that's where f prime of x is 0. So this is a max and a min. It's a plus minus minus, plus plus minus, so plus minus plus, right? So the function is increasing on minus infinity to -2, it's decreasing on -2 to 3, and it's increasing along here, okay? So there's a local max at -2, f of -2, which we don't know, and a local min at 3, f of 3, which we also don't know because we don't know what f is. We're just going to approximate what f could satisfy this. All right, now let's do the second derivative. F double prime is 2x minus 1, and this equals 0 if and only if x equals 1/2. So we have an inflection point at 1/2, and this function is concave down from 0 to 1/2, so minus infinity to 1/2, and concave up. So there's an inflection point at x equals 1/2, comma f of 1/2. All right, so let's produce something here. So we have -1, -2, 1, 2, 3, -3. All right. So our x values that we're concerned with are -2. There's a max. So over here at -2, there's a max. So this is just notes to myself. 3 is a min. 1/2 is an inflection point. And we want to be concave down and concave up. So here we go. I'm just going to put, arbitrarily, I'm going to put that there. Okay, so I know it is a max here and it's concave down. Oops. I know at 1/2 it changes from concave down to concave up. And then I know at 3 I have a minimum down here like that. And this is a graph. Here's my inflection point. So this is the concave up bit. There's my max. And this is the concave down bit. Sorry, this is concave down, this is concave, and this is my inflection point. So this works. And your graph could look completely different than this. It would have had the same shape, but it just would have been maybe higher or lower. Now in Calc 2, if you take Calc 2, which I think most of you will, if you take the antiderivative of this thing, you get 1/3 x cubed minus x squared over 2 minus 6x plus a constant. And this function, if you graph it for any c, will satisfy all these things. So 1/3 minus a half minus 6. So So 1/3 x cubed minus x 1/2 x squared minus 6x I'll just put plus 1 in there. So notice there is a max at -2. There is a min at 3. And I don't know where 1/2 is, but see, there's 1 about right there. I can't do it on the page, but that's where the inflection point, it goes from concave down to concave up. Alright, well I did 3 of your 10 problems and gave you a good feeling, I hope, for how these should go. I hope you had a great weekend, or you're having a great weekend depending on when you see this. And thanks for tuning in.